Hi, I will give you a demo of our walkthrough of our reliability analytics and benchmarking system. So I'm just logging into the application. So we have a section where all the reliability analytics can be viewed. So as a first step, if you see there are two distinct features which is required. One is if there's an existing ERP system such as a SAP or a Maximo or where the maintenance work orders are issued, you can either have an interface to those systems so that the data collection is automated. Else, we have also given an option for uploading the work order through a Excel format. So when you click on this section, you will have a feature to Excel the data upload. So to see what the data format is, we have created some sample format. So I've just prepared a sample format for the maintenance work order details. So you can see this is the standard format. We have equipment IDs, work order number, the start date of the work order, start time, end date of the work order, and end time, right? And manpower cost, material cost, production loss, other cost, and total cost. And in terms of the cost, we have given these four factors. In case if a particular organization has more, we can configure the same, or if we have less also, we can configure based on your need. And these are all configuration which is done to the system. And this is a maintenance code or problem code which is which is assigned for each of the work order to ensure that this work order is executed because of either these problem codes. It could be calibration error, or it could be a barrier problem, or sensor damage, or whatever it is. And similarly, the maintenance time, it could be breakdown maintenance, condition based maintenance, or preventive maintenance, and whatever it is. So this data we take it from the ERP and prepare Excel, and the same thing is going to get uploaded into our system. So I'm just uploading the file. So the moment you upload all the data, everything gets goes into the system, and the system is ready for any further analysis. So you can see upload successful has come. So now I go into the analytics section where we can view the complete details. So this system provides multiple level of views for making an informed decision. The first is on all analysis are based on data science and statistical techniques. So if you see the first section talks about the frequency of occurrence. So I can tell the system. So for example, from this date, so till today, get me all list of all failures. So this will give the complete failure patterns, which equipment has failed the most in the plant, and Pareto analysis will be displayed. So this will help us to identify, for example, if you see in this example, we are given three tags, which is F10101, P10101, and P10101. The frequency of occurrence during this period, I have given it here. And in terms of Pareto analysis, you can see the complete picture. Right. So while there are multiple views, as I told, this is based on frequency of occurrence. But in actual plant, particular equipment might have failed only once or twice, but the cost of maintenance could be more. And certain equipment would have failed multiple times, but there could be a negligible cost. To analyze those, we also have a view where we can look at the cost of maintenance. So for example, for the month of April, I want to do the cost of maintenance, review how it is. So during this month, if you see, you can see the list of equipments which has costed the most in terms of maintenance. You can see such reports. P10101 has costed the most, F10101 next, and T10101 is the third. Next, you also have a facility to benchmark. So this benchmark feature is pretty unique to this application, where it is just like a company's financial performance, which is declared every quarter. So here you can organizations can decide on what frequency they want to benchmark their maintenance function. So for demo purpose, I've just added every month. I have created some value. So I'm giving for the month of April, I want to create a baseline 14. I generate the baseline report. So once I generate a baseline reports, all the algorithm, inbuilt algorithm calculates the complete details for each equipment and benchmarks the same. So these are the things which is getting benchmarked. You can see for each equipment, what is the number of breakdowns during this period, what is the cost spent on maintenance average, what is the standard deviation of cost spent. So it's not only average, it's also variance is calculated. Mean time to repair, standard deviation, mean time between failure, standard deviation, and what is availability. And similarly, it's not only for equipment, even for problem codes, you can see the cost spent. For example, barrier problem 16 times it has failed, and this is average cost with a variance. So like this, you will be able to create the benchmark, and this algorithm is generated, and now if you save it, this baseline is saved. So now all these are available for complete view. For example, you want to go and study. Here you can see we have created some 14 baselines as of now every month. So I can just check the latest baseline and view a report. You can see this. And similarly for problem code, you will have a similar view for viewing the baseline. Then you have also a feature where you can compare baselines. So assuming you review the parameters, review the statistical charts, and this helps you to identify action items. And so now once you implement the action items, you can see whether those action items have yielded the benefit or not. So now I am comparing the baseline 13 and baseline 14. So here you will see certain equipments which has yielded improvements, certain improvements have been deteriorating. So it's up to the maintenance staff to compare all of these. So here you can see a number of breakdowns has increased for this F10101. But cost of maintenance has come down. Standard deviation is also almost similar. And mean time to repair has come down. A standard deviation is uh, almost similar. Mean time between failure is also come down, which is a negative signal. And availability has increased. If you see the other equipments, P101, the cost, the frequency of failures has increased. whereas in T101, the number of failures have decreased. So you can see from this basically how the equipment failure patterns are there. Then you also have a maintenance analytics where you can look at the failure patterns. So this system helps you to diagnose, not only look at various type of failures, which equipment, identifying the bottleneck for each department, but it will also give you the failure patterns in terms of what to look at. So here you can see barrier problem, calibration error, sensor damage. These are all the problems, and these are the equipments. And you can see these details and frequency of failures. So if you see F10101, I think barrier problem has caused the maximum damage. And next is the sensor damage. So as a maintenance department manager, I will be able to pinpoint the reason for each failure pattern of each equipment and probably define an action item which can improve the overall failure for this equipment, also may improve the cost of maintenance. And I also have a section on cost analysis. So here again, you can look at various factors of the cost. So you can see here basically for each equipment, what is the manpower cost, material cost, production loss, other costs, and total cost. This is a percentage. So you can see 63% is related to manpower cost, and material cost is 6.4%, and production loss around 25%, and other cost is around 5.27. So all these are completely configurable based on what you need. You can do it. And you also have a Pareto analysis on cost of maintenance based on the baseline report. You can see the failure patterns. So you can see cost and average percentage cost and cumulative one. So this is a view. And the other thing is you can also have a department level view where for each department can look at their equipments in silo and find out for their departmental total cost spent on maintenance for their department, which equipment has costed the most. So you can see the equipment cost for each of these equipments, it has come down. And where the department cost, all these data are the same. What is the total manpower cost, material cost, production loss, which has been executed during, which has incurred for the department. And for this total cost of the department, what is the each equipment, how much it has costed in terms of manpower, material. So you have multi-dimensional view. If you want to focus on manpower cost, you look at which equipment has costed the maximum. If you want to focus on production loss, you can see which equipment has costed the more. Or if it is a spare cost, you can look at what is a material cost. And like that, whichever is the area of interest for you, you can look at it comprehensively and identify those action items which will lead to improvement in equipment availability and decreasing in the cost of maintenance. So that way you will be able to achieve both the objectives. And finally, you also have a section where you can compare the cost analysis. So the action items which you have identified here can be tracked, and after it is implemented, you can verify whether the subsequent baselines are included, given the necessary improvement which you want. this value is more in terms of the cost. So you can see here. So here it was, this has increased basically. This is the green is the manpower cost has increased between this and this time. And whereas your the cost in terms of material cost is almost the same, and against overall departmental cost, and you have the production loss has increased, and the green ones other cost has also increased. So this gives you a comparative analysis between the two benchmarks. So this system gives you a complete back details of rich analytics, where it automatically processes the work order data. It eliminates all the special causes, and we have a algorithm takes care of all the special causes, assignable causes, and all, and then uh, uh, gives out the data in a format which can be viewed and taken forward. Thank you.